Good morning and welcome back to day 2 of AI Engineer Melbourne. I hope you had a really good day yesterday. See how animated people are today. Did you have a good day yesterday? Oh yeah, see, that's how it happens. All right, so thanks for coming along, being involved. Hope you had a great night at the drinks. There's a lot of energy there. We got a whole other day today. We've got a lot for you, and then we have some drinks to finish up as well. But we are beginning with a genuine privilege. So Jeremy Howard is one of the really unsung legends. I mean, he's sung, but I think not as much as he should be, in particular because he's Australian. But his work in machine learning and AI go back many years, in fact, and before that, he's the founder of Fastmail, which many of us will use. He wrote a paper and developed a technique called ULM-FIT, which is essentially the foundation of modern large language models. And the work that he did there sort of helped kick off the revolution that we're all kind of being part of. So we owe an enormous debt of gratitude to Jeremy and his work there. He is now the founding CEO of Answer.ai and the co-founder of Fast AI, who are looking to make deep learning accessible. So to kick off this morning, would you please welcome, and let's express a huge round of gratitude for the work that he's done over many years for the Australian industry and then around machine learning and AI, Jeremy Howard.
Cheers, thanks for that. It's nice to be back in my hometown. It's good to see you all. I have a bit of an unusual talk I wanted to give today. The first half of it's about psychology rather than AI, and hence the title, which is about growing on purpose and the work that makes you. It's such a critical moment in our history right now, and the work that we're all doing is changing. And I want to share with you some key findings from the last 50 years of research about how your work makes you. And so then you can make informed choices about the work that you choose to do. And in particular, I want to draw on this paper. It's not just a paper. This was a review paper at the end of 30 years of research representing hundreds and hundreds of experiments that led to this huge overarching thing called self-determination theory, or SDT. But I just want to read you the first 2 paragraphs of this, and I want you to have a think about it. The fullest representations of humanity show people to be curious, vital, and self-motivated. At their best, they are agentic and inspired, striving to learn, extend themselves, master new skills, and apply their talents responsibly. That most people show considerable effort, agency, and commitment in their lives appears, in fact, to be more normative than exceptional. In other words, this appears to be how humans are born to be, suggesting some very positive and persistent features of human nature. The very next paragraph continues, yet it is also clear the human spirit can be diminished or crushed, and that individuals sometimes reject growth and responsibility. Examples of both children and adults who are apathetic, alienated, and irresponsible are abundant. Such non-optimal human functioning can be observed not only in our clinics, but also among the millions who for hours a day sit passively before their televisions, stare blankly from the back of their classrooms, or wait listlessly for the weekend as they go about their jobs. So here we have an interesting bifurcation of the observations about the nature of human flourishing and the fullest representations of humanity that we observe. There's been thousands of years of history and more recently many decades of psychological research looking at this difference between eudaimonia and hedonia. So hedonia is where we get the word hedonics or hedonism. There's nothing wrong with it per se. It's that frictionless, pleasant ease, pacificity, and kind of easy pleasures. Eudaimonia, on the other hand, is what it turns out that these fullest representations of humanity are about. Fully actualizing your capacities. That turns out to be what it means to live well. And as I say, there's hundreds of experiments, there's randomized controlled trials, there's bucket loads of research behind this. This is not just a crazy idea somebody randomly came up with. So one of the sub-pieces of SDT, self-determination theory, a key sub-piece, is around motivation. Now, why is motivation important? Interestingly, when I've read about motivation in books like Dan Pink's Drive, which is a great book, and some of these ideas come from the research in that book, tends to talk about, like, how do you get people to do stuff for you? You know, how do you get workers to be productive? But it turns out actually motivation is much, much, much more important than productivity. It turns out that the research shows people whose motivation is authentic have more interest, excitement, and confidence. And yes, that does manifest as enhanced performance and persistence and creativity, but it also has enhanced vitality, self-esteem, and general well-being. So motivation is key to this kind of flourishing, this eudaimonia. SDT has three particular axes, and then I've added on one more, which is very commonly seen to create these four, which is it comes from autonomy, mastery, relatedness, and purpose. Relatedness is all about connecting with other human beings and feeling supported and part of a group. And purpose is all about what you're doing something for. Is there something worth doing? I'm not going to talk much about those two today. They're very important, but they're rather orthogonal to the points I want to make. So I'm going to focus on autonomy and mastery. Interestingly, there's another few decades of research from a completely different part of the research community that have looked at the opposite question, which is rather than what helps achieve human flourishing, is for those who are very much not, which is those with clinical depression, how do we pull them out of it? And interestingly, the research shows something very similar, which is perhaps the most effective action, even versus antidepressants, cognitive behavioural therapy, and so forth, is this thing called behavioural activation, which is basically the same thing, helping patients to engage with actions which bring a sense of accomplishment. So from both angles, you know, going from kind of, yeah, I'm fine, I guess, to I'm thriving, or going from, Jesus, life's getting me down, to getting by, the same actions from very different parts of the research community show to be very effective. You've probably heard about flow, and flow fits in here a lot. This is particularly the work of Csikszentmihalyi. And I wanted to be careful to define flow here because flow is so key to this sense that leads to flourishing. So flow should be a sense that one's skills are adequate to cope with the challenges at hand in a goal-directed, rule-bound system that provides clear clues as to how well one is performing. So one of the greatest experiences in my life was getting really good at riding a motorcycle fast around the Phillip Island circuit, and that is exactly that, very goal-directed, rule-bound action system, very clear clues as to how I was performing, and that sense I'll never forget, you know, of extraordinary flow. Interestingly, however, Csikszentmihalyi also talks about junk flow or dark flow, which is something that can look a lot like flow, but is very bad, which is you can get addicted to a superficial experience that may be flow at the beginning, but after a while becomes something you become addicted to instead of something that makes you grow. And there's a lot of research and studies around this. And in fact, the way gambling establishments. The way casinos are set up is specifically designed to capture this kind of dark flow, to give you what's called an illusion of control, and to create this kind of addiction. Rachel Thomas, I really encourage you to read this article if you have a chance, talked about breaking the spell of vibe coding, in which she noted how certain kinds of interactions, coding interactions with an AI, can absolutely harness this kind of dark flow. So you get this kind of positive flow when you have a high level of challenge and a high level of skill. It's interesting and a bit scary to note how it's quite possible to end up with this kind of pulling the slot machine lever version of flow if not careful. So interestingly, a lot of people are now saying, oh, that's happened to me, or that's happened to my friends. People who have previously been extremely positive about agents and using AI encoding and so forth. I think Armin was one of the particularly interesting ones. You might know him as the guy who created Flask, been a very important software developer. And of course also George Hotz, who created the Comma self-driving AI system and the original iPhone hacker and so forth. I've got some quotes from Armin here, though, that I thought was interesting. He said when for months, he was in this situation where the dopamine hit from working with these agents is so very real, saying you feel productive, you feel like everything's amazing, and you go deeper and deeper in this belief that it all makes perfect sense, but it's decoupled from any external validation. And so we're kind of starting to see these concerns. I saw this like 2 days ago from a guy who's been working on this kind of new GPU functional programming system, who was saying like how cool it was that he went from 0 to 95% in his most recent project in 5 hours, and then realized like, oh, 15 hours later, I'm still not there. And I keep finding problems, and I actually don't know if there's still problems, and so actually at this point I don't even know where I stand. But getting the first 95% done in 5 hours sure felt good, but did I actually achieve anything by using AI, other than that dopamine anticipation? So I think it's very encouraging that thoughtful people in our community are reflecting and sharing their reflections. In fact, one of our own community members put this up on our Discord the other day and was asking for feedback from our community. Talking about the product he works on, it's genuinely interesting, the problem requires deep domain expertise, but it's hard for us to verify because we've got 200,000 lines of kind of vibe-coded software at this point. And he's actually realized the pace we've moved at has slowed down as models get better and token speed spend increases because we generate more and more code with less and less careful engineering. Debugging failures, he told us, is super painful. And interestingly, again, I guess this kind of dark flow idea, most of his colleagues feel they're making great progress. But then when they have quarterly meetings with management, they get a reality check when they have to show what have you shipped, what's the accuracy, how many clients have you signed, and they suddenly realized the results actually weren't good. I'm not going to go too deep into negativity. We've all seen it. It's in mainstream newspaper articles nowadays, Wall Street Journal, I think just today, Uber's now saying they're putting a strict budget on token use because they're not seeing the ROI. And so rather than dive into some kind of like AI negativity, I instead actually want to point out something that is, you can go in two totally different directions with AI. And I'm looking at two of those key motivation platforms of autonomy and mastery. And it's certainly true that AI can decay those things. So I'm sure anybody who's kind of done lot of agentic work and vibe coding has been in that situation where we have what psychologists call an illusion of control. The agent's asking you, like, hey, do you want to go with a distributed system here, or would you rather use green threads with a polling loop or whatever. And you're like, I don't know what any of that means, A or B, A. So this is something that actually decays autonomy. On the other hand, AI can be used to support your growth. It can be teaching you things, you can be trying things. It isn't necessarily creating more outputs more quickly, but it's definitely something that can happen. So ditto with mastery, right? Mastery is not in SDT. It's not about creating more outputs, creating more products. It's about creating this genuine ability to craft something. It's effortful and involves learning from that effortful work. So with AI, you can tackle more complex tasks and you can focus on learning those underlying foundational principles and master your craft. Or not, right? You could focus on outsourcing more and more to AI, more and more quickly, with less and less effortful practice, getting less and less learning. So AI is neither good nor bad for you, for your psyche. But warning, the people getting you to use AI don't care about your autonomy and mastery. They care about your outputs. And so they're going to put you in the decay world all the damn time. The people who are selling you the AI models, platforms, harnesses, and your bosses at work who need to be able to show their quarterly token maxing metrics. So you need to look after yourself in this world. So I want to show what it looks like to have amazing mastery over a computer and how that's changed over a period of time. So this is Ivan Sutherland. I've done this at 2x back in 1963. 1963. And he's shown how he's able to create a direct interface between himself and a computer where he's drawing with a light pen. You don't see it with one other hand. He's pressing buttons to set constraints as he's drawing. He's using it directly against one of these, I think this is one of these fancy vector monitors. And he's showing the interviewer here how he can create an arc, for example, using these constraints by drawing directly on the screen. And he can adjust it. This is an extraordinary level of deep connection between the human and the computer. You might have seen this, the mother of all demos. This was 1968 that this happened. Very similar idea. So in the mother of all demos, Douglas Engelbart introduced for the first time the mouse, hypertext, real-time collaborative editing, video conferencing, word processing, screen windowing, and dynamic file linking. This quote was in 1962, towards the start of this project, and the demo was in 1968. And his goal was the same, augmenting the human intellect, so that the entity to be produced will exhibit more of what could be called intelligence than an unaided human could. We've amplified the intelligence of the human by organising his intellectual capabilities into higher levels of synergistic structuring. So you see, it's very similar between what Sutherland was doing, what Engelbart was doing. This was their mission, was to amplify and augment human intelligence. One of the most underappreciated, most extraordinary people in the history of computer science is Kenneth Iverson. I mean, not that underappreciated. He got the Turing Award. But he designed APL. APL is a new notation, or was a new notation, for representing computation and mathematical thinking. This is from his Turing Award presentation paper. If you don't know APL, it won't look very familiar, but what he's showing here is he's proving some characteristics of the inner product in his new notation. And one of the really interesting things about this, if you ever get into APL, and I strongly recommend it, is it turns out that this generalizes in a much deeper way than normal mathematical nomenclature, in that the inner product in APL can actually is an operator that can combine any two functions. It's not necessarily multiplication and addition. And so suddenly he's proved a whole class of features about a whole class of functions, many of which had never been looked at by a mathematician before, just through notation. And this can go a really long way. Some of you might have seen this very famous single line of code in APL, which is a complete implementation of Conway's gain of life. So here in this video, that life function is being applied over these two characters, and off it goes. Again, it's the same thing, right? Iverson was passionate about creating this connection between the human and supporting the human's thinking, notation as a tool of thought. Perhaps most mind-blowingly, Brett Victor, who spent a couple of years, as he described, being a hermit living on a train. And he came out the end of those 2 years of hermithood having built the most extraordinary and inspiring array of real-world demos showing about how to understand climate, how to understand electricity, how to understand how to build games, how to build graphics, how to understand waveforms. And he shared this all with the world. This is his coding environment, whereas he changes it graphically. This is his amazing game-playing demo where he actually created a time machine for his code. If you haven't seen this, please watch everything Brett Victor's done, because it's incredibly inspiring. And all of it, you'll see, all of it's the same thing. It's creating this connection between the human and the computer that they're working with so that they can craft. This is all effortful craft that he is supporting. Chris Lattner, this is his playground system. He's created a whole amazing hierarchy from LLVM, Clang, Swift, Playground, MLIR, Mojo, at every level, trying to improve this ability for humans to connect to and work with their computers. My argument is that actually we're still on this chain. We can continue working along this history from the mother or demos in a really deep and powerful way. AI is a marvelous way to connect more deeply with our computers and achieve this fullest representation of humanity. So this has actually been kind of my mission for the last 30 years and very dramatically for the last 10. And at Answer AI, it's all of my focus, this idea that we should be seeking to augment human creativity, not to replace it. It's interesting to see, hopefully this resonates with you, but also hopefully you see this is almost never what you actually see as being marketed when somebody's trying to sell you a piece of AI. It's like it's going to summarize this for you, it's going to write this for you, it's going to do this for you. It's all about being done for you. So I want to quickly demo something we've built to give you a sense of what it looks like to have a tool that is specifically designed for this augmenting human creativity and understanding, indeed. And so I'm going to do it. I'm going to just show you a couple of examples of actual dialogues I've gone through with the help of AI in the last 3 days. So one was I wanted to learn about recursive language models. So probably a lot of you have know about recursive language models. They've been kind of taking over the world. So we've got this system called Solve-It. So I should show you solveit.com. And I loaded the paper, recursive language models paper, into Solve-It. And you can just read it in the normal way, piece at a time. But make sure you understand it. And so here, I looked at figure 1. I was like, well, I don't know what this is, or this is, or this is. And so normally I might just skip over it. But here I can just say, hey, what's this figure? And it tells me, like, okay, these are the 3 evals that the RLM authors are doing here. And interestingly, it's like why. It's going from a constant to a linear to a quadratic complexity, which is not actually captured in the original papers. That's really helpful information. Now, I don't work very well at an abstract level. I need things to be concrete, so I could ask for an example of each task, and this is much easier than going into the papers and trying to dig them out and so forth. And so here I'm getting little examples. It's like, okay, I get it. Right, so I always tell people, don't move on when you're learning a new thing or working on something until you get it. So I was like, okay, I get it. So then there's another figure where they describe it. I didn't fully understand this figure, to be honest, at first. And so it tells me what the key pieces are. It's very handy. So when I'm reading this, I'm thinking like, okay, I want to push beyond this. I want to understand it, but try and go a bit past it. So I'm thinking like, okay, I wonder if we can replicate all of the features of an RLM right now. So I kind of had a hypothesis about how to do that, and I kind of check with the AI like, I think we can try this ourselves. And it clarified some key points about where subagents fit. And as it turns out, Solvit has a subagent. So I said, yeah, you've got a subagent, why don't you try it? So in this case, it spawns an agent and tells it to use Python to solve the complex square root. And we can also write code here, right? So I can then try it myself and I can compare. I'm like, oh, cool, okay, so I've kind of confirmed I'm in an environment where I can actually do the same things that the RLM paper did. So another thing I mentioned as I read papers is often it's very easy to skip over citations, right? But here it says, well, here's recent work. I'm like, well, okay, I don't know any of these, so I shouldn't keep moving. So I said, like, stop, can you please go and read all those papers for me and tell me basically what they are and why they're here. I can decide whether to click on those links, read them on myself. And I want to kind of test my understanding at this point. So anyway, to skip ahead a little bit, I'm thinking like, okay, let's try it. So they've got their table of results here for 4 different tasks. So I'm kind of thinking like, I'm not sure that this thing called an RLM even exists. It just feels like a normal tool loop that happens to have particular tools in it, and I seem to have the same tools right now. So I think we can be an RLM, can't we? So I said, let's try it. Let's try this code QA thing. I've never heard of this before. So it tells me where to find the data. And so I start, so it writes some code for me, which actually didn't work, but then it can help me debug it. And then I can test it, and then I could experiment and look at this data carefully, make sure I understand what this eval is and how it works. And then I just tell it, like, okay, solve it. Go ahead and just solve this right now. And so this is one of the things in one of the evals, and it goes ahead and tries to do it, and it says, I think the answer is B, and they check, oh, it is B. No, tell me how you did that. And then, okay, let's try another eval. And answer is C, yep, answer is C. And so this is very interesting. So I did this for a few different tasks, including the hardest quadratic tasks. So I downloaded another of these data sets, went through them, and discovered that Solvit correctly solved every one of the tasks. And so I've now, not only do I understand RLM, I've re-implemented it. This is all in the space of a couple of hours. And in fact discovered that this is a much more powerful platform than even RLM is. Another example was I was looking at Julia Evans, who's a fantastic writer, always really interesting, and I'm not a fan of Tailwind, and I was keen to see how she had done this article called Moving Away from Tailwind, which had a particular structure. This was the structure she had, and I decided, okay, I want to go through her blog post. So I loaded the blog post, as you can see, into Solve It, and started reading it. And again, so the red is me asking questions as I go through the article. And so she said she used something called Tailwind Preflight as her starting point for her styles. And it's like, well, are there other options? So I went and grabbed it. And actually, one of the cool things about Solve It is because it's in a browser, I've got actual styles, HTML here. So I'm actually modifying my environment as I go. And so I can see this happening, and then I can try it out. So I'm trying out layers. I'd never done anything with layers before, so make sure I understand how they work. But again, I'm actually using them. So before I actually used RLM, or rebuilt RLM inside Dialogue, here I am rebuilding Julia's styles inside a Dialogue. She had a section about components, and again, same thing. I started creating the components myself, as you can see, with the help of AI to make sure I understand. So here I've got a badge component, for example. And this is all real, right? I'm creating actual code. I'm seeing it actually running. Button components. Then very interested in colors. I kind of had some ideas about how to create a new color framework. So I kind of, bit of a discussion, as you see with the AI. But again, the AI didn't write it for me, right? I kind of came up with this idea of what I think I wanted to do. And then I tried it. And you can see I've created my own new color palette that I'm very happy with. And I thought, oh, cool, I'll try and map those to kind of semantics now. So I like, okay, which should danger be? So like it helps me show me what it looks like, different colors on different backgrounds, inverted ones. It helps me create these full swatches so I can see how my color palette looks. Did a similar thing with font sizes. I had an idea of how I wanted to create nice typography. So again, kind of write the code, talk through it, and have a look to see. And I'm like, oh yeah, they all look pretty good.
Thank you. So
by craft field, right? I normally talk about software engineering being a bit of a canary in the AI coal mine because we applied it there very early and it's very applicable to software engineering. But, it's all still changing and we don't really know where it's all going yet. We certainly have more questions than we have answers, which is why we're all here, to share and learn from one another. But I'd love a show of hands, actually. Who in the room thinks that it's just another evolution, another step change in the long history of computing? A few hands, okay. And who thinks it's more of a revolution, something that's genuinely new? Okay, I think I see more revolution hands, but, it's actually pretty mixed. Well, I think we're all still trying to work that out. Nobody really knows where this is all going. And it's those very questions that took me back to university at the beginning of 2024, because I really wanted to understand this more deeply. So I did a Master's of Engineering, took me 2 years part-time, and I designed a longitudinal study with 2 questionnaires spaced 6 months apart that I ran at the end of 2024, beginning of 2025, to look at the lived experience of professional software engineers who are using AI, either at work or at home. I got participants from 28 countries, and today I'm going to share 4 of the findings from that research for you to contemplate, take away with you. So one of the things I was really interested in understanding was whether AI coding assistants shift our perceived focus across these common development tasks that we all do. And most engineers felt that they spend less time on all but one. Reviewing code was the only one that was slightly those 2 time points, because over that 6-month period, we saw a statistically significant shift from the more creation-focused tasks to the more verification-focused ones. And what that tells us is that the very nature of the work we do, or the craft of software engineering, is changed. Those common tasks, does that mean that we've got a whole bunch of free time on our hands now, and we're all going home at midday and we're going to the beach and relaxing? I don't think that's what we're feeling at all. I know that it's not what I'm feeling. I'm busier than I ever have been. And it was different enough to the other standard sort of software development tasks I just mentioned. So I've given it a new name, supervisory engineering work. And it's made up of directing AI, evaluation. I think it sits right in the middle in a new loop. I've called the middle loop. But note that the dimensions of craft, they don't disappear. We're now just applying them to a new type of work. Productivity and developer experience travel together. They're correlated. And leaders have been told, if you want to improve the productivity of your team, focus on improving the developer experience. So I asked engineers in my study, did they feel more productive with AI? And of course, most said yes. 84% did at both time points, very stable. But those same engineers were starting to report a decline in their developer experience. And by that I mean one of three dimensions: cognitive load, flow state, or feedback loops. And I said that at least one of those three had declined or gotten worse. And by the second time point, 6 months later, that number had almost doubled to 27%. And it was flow state that was the most negatively affected, followed by cognitive load. That was increasing. Feedback loops was improving, though. And the fact that we're getting more feedback more frequently is actually interrupting our flow. Correlation there. Side effects, right? But note what's happening. We feel more productive, but the very things that made the work feel like a craft are starting to erode. So if you're feeling a version of this, know that you're not imagining it. The research is starting to show it, and giving it names like AI burnout. If you haven't read it yet, Steve Yegi has a really great blog post called The AI Vampire, on which he talks about this as well. And for the leaders in the room, please make sure that you're taking note of this as well. It's not sufficient to try and measure productivity alone, because you'll... So anyway, this is all sounding pretty grim, so I hope that the next and last finding that I'll share with you will give you as much hope as it gave me. So of all the research questions that I had to answer, I figured that demographics would play a big part, that they would matter. So things like your seniority, the size of the company you're working for, that sort of thing. But it turns out the strongest predictor of productivity in those three dimensions of developer experience was something called self-efficacy. So self-efficacy is your own belief in your own ability to accomplish something. So engineers who felt more confident in software were over 10 times more likely to report higher productivity gains. That's a really big effect, and I'll tell you why it matters. Because self-efficacy is a belief, and you can change your belief much more easily than you can change your demographics or your work situation, right? Stuck where you are, you don't have to wait for the perfect title or the perfect tool to come along. You can actually get going right now. And self-efficacy is built up through mastery experiences, which you can gain through experimentation. The more you experiment, the more you learn. The more you learn, the more confidence you gain. The more confidence you gain, the virtuous cycle builds from there. Right? So you're far more in control of how you react to this moment than you might have thought. All right, so the very nature of our work is changing. The craft is relocating. What does the future even look like for us? I'm not an oracle. I don't have a crystal ball. By a paper that I read recently. It was written by some of the same researchers that created the space framework, if you're familiar with that. And they described these three possible futures. Now, I've given them slightly different names, but I was inspired by their work here. So on the one hand, you've got the artisanal developer. That's, think possibly restricted to the more safety domains or heavily regulated environments. Now, I think this type of, there will be a demand for this type of work, but it might be quite rare. On the other hand, you've got the clerical coder. Now, this is the one to watch out for, because I think it's the one that's probably got the least amount of joy built in. It's doing a lot of work overnight. You come in the morning and you just accept those PRs uncritically. Where's the creativity in that, right? So that's the one to avoid. And in the middle, we've got the orchestrator or the code conductor. We're going to give these things funny names. But that's probably the same. And think building software with agents at scale. Now, depending on where you find your joy, you might find yourself leaning towards one of at least two different directions. If you're more interested in really understanding the problem, the domain, then you might lean towards being more domain-focused, capturing the what and the why in intents, in well-written specs, and you're feeding that to the agents. On the other hand, if you're more interested in building the machine that builds the machine, then you might be more, leaning towards that harness, making the harness by the future of work looks like, and then create the pathways by opening up the opportunities, blurring the lines, and encouraging them to move towards it. And remember that pride and joy, they don't just happen by accident. They're outcomes that you can design into your system. So that, my friends, is the leadership work for you. All right, to wrap this up, nobody has this all figured out yet, right? Literally nobody, not the top practitioners, not the tech leaders, and not the academics. Trust me, I know I have been in rooms with all of these people just this year, and they all have more questions than they have answers. We've all been rebooted. We're all just explorers now, and we're writing the path as we walk along it together. The future is yours to imagine, so take the opportunity to design the craft that brings you the most pride and joy in your work. Because as engineers, we've always designed for the future, and now we get to design our own. And that's all.
Thank you so much, Annie. Lots of thoughts, lots of anxiety that I hear from many folks in the industry, and it's very understandable. So, very, very helpful way of framing the challenges we have, whether we're leading folks or whether we're kind of being directed around. So, next up we have Mike Neale. I've known Mike for far too long, not because he's an awesome person, but it demonstrates we're getting on in years. And he has been involved in the Australian technology industry in many ways over a very extended a period, over 20 or more years now that I've known him. So he was an open source architect at Red Hat, the co-founder of CloudBees, and he's now the principal engineer at Block, where he works extensively on open source and their Goose, Project Goose product. But he's here to talk about something different. So obviously we have a massive constraint in computation. Meanwhile, there's lots of computation in the world. It's not sitting in data centers. It's sitting in this room. I don't know what the rough estimate will be, but would we have the equivalent of what sitting on our phones and our laptops and so on in this room? And it's just going to waste almost all the time. Like we build these devices. So we're very concerned about, for example, the climate impact of data centers and computation. I think it's a very legitimate concern. But it's not just the electricity to do the computation. We are making phones. We are making laptops. We're making desktops. And that embodies probably the significant majority of the total energy consumption of that device over its lifetime. And then we have them sitting there completely idle almost all the time. So Mike is trying to do protocol devices. Implications about who owns computation, where sovereignty sits. Are we going to be forever dependent on a small number of hyperscalers who have the capital and the wherewithal to build the compute that we all then just rent from them? Or is there another way? Well, Mike has some thoughts and, more importantly, actions around that. It's amazing work, and it's a privilege to have him come and speak about it. Please welcome Mike Neale.
Thank you. Thank you. You can hear me okay? Great. Yeah, so, compute is all around us. It's in this very room with us. Quite a lot, actually. A lot of it's idle. Not all of it's idle. I can see a lot of people writing right now. It's getting expensive, as people are starting to find. It's very, very resource heavy. It's not always the most efficient thing with the hardware that's used. And of course, there's lots of consumer stuff together versus the deployed fleet of AI specialist stuff from 2025. The bar chart kind of looks like that. There's a lot of consumer stuff out there. And it's not like you're not comparing apples with apples, but it just gives you a taste of what's going on, just the sheer power of compute that comes out of Apple devices and other things out there. That's just being bought every year, renewed, or just sitting there idle. It's been there for years. So why do we want to do that? Well, John kind of talked about this a bit. Sovereignty has been talked about this week a bit. Sovereignty is just kind of giving you optionality of where things run, so you don't have to rely on a optic fibre that goes out. That's the one that goes out from Bondi Beach and heads across to California. Your data doesn't have to go there if you've got national sovereignty, and for some reason in this diagram it's going via New Zealand, which is chilling. Would you do things differently if you had zero marginal cost? Like if you had, this is one of the things about local models or personal stuff is you're not diverse collaborating from all over different companies. So there's no incentives for the public one. This is not a scam. This is not an attempt or anything. It's really just a proof point. So yeah. And that's where we are. So thanks again, everyone, for having me. This is the technology we use, and this is some links you can follow up. So thanks.
Thank you so much, Mike. You can probably hear my voice is going. Don't worry, if you're sick of my voice, imagine how I feel. All right, now to round out this round of talks this morning, we have a genuine treat for you. So I was up at the Sister Conference AI Engineers Singapore just a couple of weeks ago. Some really amazing speakers up there. And one of them I heard speaking on the first day, the leadership track, was Jishwan Lee. Now, Jishwan is the head of ZAI. That's how it's pronounced. It's not ZAI. It's not Zai. And Z is, I'm not going to pronounce it. Go and find Shapu or Jishwan. It's the Chinese word for intelligence. It stands for that. ZAI is one of a number of Chinese companies, model labs, who are very fast followers